Hello everyone. I thought that I might put up a short video about some of the questions that you're going to see in your homework for section 6.1, 6.2, and 6.3. I know when you're first learning trig, it feels like there's a lot of information and there's a lot of words floating around with your numbers. And so sometimes that can get a little confusing. So I'm just going to start off real quick about the unit circle, what the unit circle is, and then I'm going to do, I think I have one question from 6.1, two from 6.2, and one from 6.3. So you kind of have an idea of where to get started. All right, so the unit circle is where we're going to build all of our trig off of, and we are not creative in math. We call it a unit circle because it's a circle and its radius is 1 unit, right? Like that's it. That's how we work. So now I'm going to take that out for a second and I'm going to extend this so that I have kind of like crosshairs. Think about the Cartesian plane where you're just going to tunnel vision it in so that you're looking at a max of a 1 here. This is going to be a 1 here, and then a -1, and here's a -1, right? So think about it like a restricted domain and a restricted range if you're thinking about algebra. Now, from the unit circle, we're always thinking about from the center. Later, this will be called the pole, and when we're talking about polar coordinates. So imagine that you're standing at the very center, you're at the origin, and you kind of like throw a lasso off to the side, and you wrap that around a point along the circumference, anywhere right here. Now, you're going to be standing on this ground right here. This little angle that opens up inside of the initial ray and then ends with the terminal ray is what creates the angle. So when we talk about theta, that thing that looks like a 0 with like a line through it, we're talking about wedged in between there. The outside of this, sometimes we call it beta, right? They got all kinds of different names, but when we're talking about theta, we're talking about inside of there. It doesn't matter if it's big or small. We're talking about wedged inside of here. Now, also imagine that this rope that you threw, that it's longer than you need to get out there. And so after it kind of wraps around here, it kind of drops down, bloop, and it hits the ground. And it hits the ground at a 90-degree angle, right? Because it just falls straight down. That's the right triangle that the trig functions are created from. I'm going to call this A, B. I am going to stay with C. Most of the time you're going to see that for R because it's the radius, right? So from here, that's the angle in this story. Now in the application problems that you'll see later on, you might be talking about theta being up here, right? So theta is not always the central angle. Theta is like our x for trig, right? X can move around, theta can move around. But if we're talking about inside the unit circle, we're talking about this angle that's created at the center here. That starts at this initial ray and ends with the terminal ray. From here, you have 3 main trig functions that you're going to talk about. And all these trig functions is an ugly way to say a fraction. It talks about the sides of the triangles in terms of a word. So instead of saying the sine of theta, right, the sine of theta is going to be whatever the B length is over the C length. And we usually don't write the E, right? So that's going to look like it just says sin. So the sine of theta. The cosine of theta is A, the adjacent, over the hypotenuse, that longer sine. We just call that cos. And then there's my nemesis, tangent. And the tangent is going to be, I'll write it over here. I got a little ahead of myself. Tangent is going to be the B over the A. Now, how do you figure out what these are? Well, if you're inside the unit circle, that's great. That's got to be a 1. This is just how far you have to get to this section, and then how high up do you have to go. So it's just your x and your y. And so this is going to be your y, and this is going to be your x. And so one of the main things that you'll see a lot of is x squared plus y squared. Well, in the unit circle, that's equal to a 1 squared because of Pythagorean theorem. Now, you can't jump to r equals 1 if they don't tell you you're on the unit circle, right? So if you says it's on the unit circle, then that's a 1. If it just says, hey, you got a random circle, then you got to find r using Pythagorean theorem. Now, as this moves, I'm not even entirely sure I'm going to be able to do this. As this moves around like this, of course, this is going to stay a 1 because we know that's the radius, but now your lasso is going to hang lower, but it's getting closer to this side. So x squared plus y squared is always going to be equal to 1 squared, well, which is 1. But the x's and y's are going to change. So as this angle gets closer to this 90 degrees, then this is going to swing together, and then when it gets to the other side, oh, that didn't work out the way that I would have hoped. Let's try that again. It's going to just do the same thing on the other side. Now, when you get to the other side, it kind of feels like you went through the mirror, right? And so now this is the theta that you're talking about, but for reasons that we haven't gotten too far into yet, the calculator sometimes gets really mad at you when you go through the looking glass. And so what you may have to use is this reference angle that's right here. Now, I'm talking about angles and thetas and terminal sides, but really we got two different ways that we can measure these angles. We got degrees, which is what you're used to, and we have radians. You know degrees, 360 degrees. This would be 180 degrees right here, right? 270, 360, and you can keep going around, have reflective angles. So I can go around the circle twice and have an angle that's 720. When I graph it, it will kind of look like a 0 or a 360, but it'll have a notation like this so that you know you went around twice. But some things look really messy in degrees, and so we want to swap them over to radians. A radian, again, math class, so we're not creative, just takes that radius, whatever it is, and lays it, like molds it, so that arc length out here is the same length. And so this would be 1 radian. It would probably be about, 60-ish degrees if I was talking about the way I drew it here on the degree side. But since the good news is you don't have to eyeball it, right? Because you know half a circle is going to be 180 degrees. You go all the way around. And we know also from all of our geometry formulas that a circle is 2 pi, so halfway through is just pi radians, right? I don't need 2 pi radians, I just need pi radians. So 180 degrees is the same as saying pi radians. Now, math people are lazy, and a lot of times we do stuff like this. That's not very good. 180 does not equal pi. It's a conversion. So let's say that you run a 5K. A 5K is about 3.1 miles. But 5 does not equal 3.1, right? If you leave off the conversions, sad face, right? Now, I know that you're going to write this a lot, but just remember it's not that pi is 180, right? Pi is 3.14. But pi radians, so 3.14 radians, that's the same measurement as 180 degrees, just like I can say I ran a 5K, or I can say I ran 3.1 miles. So in 6.1, you're just practicing kind of jumping back and forth between these ideas and sketching out some things. let's go over to this one. Now, in 6.1 and 6.2, you start to look at that unit circle a lot, and it says, all right, you got the cosine of 60 and the sine of 30. What is that exact value? Well, you can plug this into your calculator, but you're not going to get a nice number. Now, if you want to plug in degrees, you have two options. You can say mode, scoot down to radian, and scoot that guy over so Blinky's on degree and hit enter. Now, when you say cos, it's going to know that that's 60 degrees, and it's going to know that that's 30 degrees, but you're still, oh, we got a nice number. You got lucky on that one. They don't always come out that nice, right? But you got to make sure that it knows. The other thing that you could do, if you don't want to change it, is that you can say cosine of 60 and then hit second apps and hit enter. So that way it knows that it's a degree and not a radian. So you can mark it. Now while I'm in there, just another thing that's in 6.1 is changing over to degrees, minutes, and seconds. Right, so you can plug something in and it will spit you out degrees, minutes, seconds in there. Here's degrees, here's minutes. Seconds, little sneaky, and it's going to be hard to see. Hit alpha plus sign. You kind of see it there. It kind of looks like an 11. So if I wanted to say, what's 30 degrees, 12 seconds, and minutes and 6 seconds. That's about that. Or I can say, hey, take that thing. I'll say 30.216, and I want to change that over to degrees, minutes, seconds. It's not going to be exactly the same because I kind of rounded, but it's pretty darn close, right? 5.76, close enough. All right, so if it says find the exact value, that's your hint to look at the unit circle. If you don't have the unit circle printed out, you're going to want to do that. Looks like this. I'm going to squish them down. All right, now the cosine on your unit circle are your x's, and your sines are your y's. Now, tangent's not on here. That's y divided by x. You can go patiently through and mark all your tangents, or you could do them one by one, whatever you want to do. But the cosine is 60 degrees. All right, so here's 60 degrees, also known as pi over 3. Cosine is a 1/2. Boop, boop, 1/2. Sine of 30, how convenient, is a 1/2. 1/2 plus 1/2. Of course, we know that's 1. The other thing that you're going to want to mark on your unit circle is something that I used to call all students take calculus. I know, not a true statement. I'm sure these acronyms have changed over the years. It's been a long time since I sat in an intro trig class. But what this stands for is what is positive in that section. So in the first quadrant, over here in the first quadrant, all of your trig functions are positive. All your sines, all your cosines, right? Because you're above the y-axis and to the right on your x-axis. So above the y. You're above the x and to the right of the y. Over here, only sine is positive, right? Because your y's are positive. You're still above the x-axis, but now you're on the left side of the graph. So all your x's, all your cosines are going to be negative, which is going to flip your tangent. In the third quadrant, tangent is going to be positive because sine and cosine are both negative, but a negative divided by a negative is a positive. So then you're back to only tangent. And here's cosine, because now I'm below the y-axis, so sine's negative, but cosine stays positive, and it's going to flip your tangent. So let's see if I can scoot this down so that we can see our next question. Where are we? Secant is greater than 0, and sine is less than 0. All right, so sine's less than 0. I know right away these guys are out. Boop, boop. I need sines to be negative, so I'm down here. But I need to remember is that secant is just another way to say cosine. It's 1 over cosine. So if secant's positive, cosine's positive. And if cosine's positive, that means I must be in the fourth quadrant. So I have this one right here. Now, for your midterm, you can have your unit circle with you and you can mark it up. You can put your All Students Take Calculus. You can label all of the tangents if you want. You can label what quadrant you're in. All of that is totally fine. Okay, 2 big questions left. This is by far the ones that take the longest, and this is going to be in 6.3. So you know one random trig function. Find the remaining ones, and there are 6, remember. So I know I got sine, and I got cosine, and I got tangent, but then you got those reciprocals. The reciprocal of sine is cosecant. The reciprocal of cosine is secant, and we're not creative with tan. That's just cotan. Sines and the S and C's flip-flop. That's how I remember. But tangent is just a big pain, and he only talks to other tangents. All right, so the sine of this angle is a negative 12 over 3. And I specifically picked this one because it's got a little bit of a pain, but at least it told you where it is. So I'm going to draw a very poorly drawn graph. And I'm between 180 degrees and 270, so I'm down here in this quadrant down here. So I'm going to draw in some random angle. And when you drop a line, you know, remember that rope hanging? This is more like a rope floating. It always drops to the x-axis. Always. You're always going to drop it to the x-axis. Theta's in here. All right, so I know that sine is negative 12 over 13. But see how they're sneaky that they put that negative out front there? It's only like a little sneaky because the radius can't be negative ever, right? And I know you went through some of those questions where you were graphing them and what it looks like when you have the negative. When you're talking about a unit circle, you're not going to talk about the radius as ever being negative. So I know my radius is a positive 13, which means that this has to be the negative 12 going down this way, right? Right. So this is my point that would be on the circle. So the y portion would be a negative 12, but I don't know the x. But I can find the x using Pythagorean theorem. So I got an x squared plus a 144. This is a 169. I got x squared is a 125. No, just a 25. So x, all right, so now here's where this is also sneaky. The square root of 25 is either a positive 5 or a negative 5. This ain't algebra. We got to deal with positives and negatives. Which one? Well, if I need to get this way, I have to pick the negative. If I do the positive, I would have wound up over here. Once you have all the sides labeled, that's the hard part. Then the rest is easy. Cosine is adjacent over your hypotenuse, right? Or your x over that r. So this is going to be a negative 5 over 13. Tangent is going to be negative 12 over a negative 5, also known as 12/5. Now it's really easy. Cosecant. Just flip it. Secant. Flip it. And I don't care if you leave the negative out here or out front or in the denominator. That does not bother me at all. Tangent. Oh, no, cotangent. 5 over 12. That's it. It's not so bad, right? So label all your sides. Make sure you go in the right direction. And then that's it. It's not bad at all. Last thing. Use the even odd properties. I'm not going to lie to you. These even odd properties, just when you forget about them, they pop back up. All right, so sine of a negative pi over 6. All right, so if you go to, actually, it's not really much of a real problem, right? Because here's 0, and here's one step is pi over 6. Well, if you think about this as 12 pi over 6, right? If I was just going to finish this, then if I just scoot back 1, well, that's a negative pi over 6. So there you go. And this sign is well, down here, a negative 1/2. What the odd-even properties say is, well, sine, that's odd, which means that you can just go to the positive version and then flip it. So I could have also looked at this as saying the same thing as this. And I would have gotten the same exact thing, right? Because sine of pi over 6 is a 1/2. Negate the symbol, negative 1/2. Cosine is positive. Or, well, it will be positive in the first, but it is an even. So the cosine of pi over 6, that's the same as cosine of negative pi over 6. See it? Right? So evens, they're the same. You could just kind of ignore the sign. Odds, you could, I don't want to say factor it out, but you can deal with that negative. You can find the positive version and then just negate whatever you have out there. And those are some questions to help you get started with sections 6.1, 6.2, and 6.3.